This is an introduction to section 14.4. In chapter 14, we are looking at work and energy. In section 14.4, we're going to have some new equations introduced for power and efficiency, and then after this section, we're going to go back to using the work-energy relationship, which is what we have here. So for section 14.4, we have some new equations. They are in this row on your equation sheet. So we have the power, this is equation 14.9, which is the derivative of the work with respect to time. And the power is also equal to the force F dotted with the velocity V. So you can see from this equation that power is a scalar. So work is a scalar, power is a scalar, force and velocity are vectors. And also, since u was the integral of F dotted with dr, force and the displacement dr are vectors also, and that's where this equation came from, this, when you take the derivative with respect to time. One thing that you do have to remember, and it's not on your equation sheet, so you might want to put it on your equation sheet. In SI units, we have a watt for power, which is equal to a joule per second. That's easy to remember. You don't need to put that on your equation sheet. But in the FPS system, you have 1 horsepower, which is equal to 550 foot-pounds per second. So when you do your calculations, you will come out with foot-pounds per second, but then you have to convert that to horsepower. So you might want to take this and write that down on your equation sheet. Okay, and the last equations that we have in this section are for the efficiency. You can either calculate the efficiency by dividing the power output by the power input, and you should be able to see from this equation that the largest value that you can get for the efficiency would be 1, because you can't get more power out than what you put in. And similarly, you can calculate the efficiency but using the energy instead of the power. So energy output divided by energy input is also the efficiency. And you can also see from this equation that the largest value that you could have for the efficiency is 1. And then they tell you here the power output will be less than the power input in real life. So the efficiency of the machine is always less than 1. You should read through the information in the green box here, and after you do that and read through the rest of the page, rest of 204 and 205, we will be ready to look at our example problems.